Prime numbers is the third topic that we are discussing under the number sense word problem series. Today we are going to see what is prime factorization. It's nothing but the breaking up of a number into product of the prime numbers. Okay, for example 42. Okay, so we are just going to break it up by 2. 21 times 2 makes 42, and you can break up again 21 into 3 times 7, right? There is furthermore breakage is not possible because we have reached the prime numbers here. So 2 times 3 times 7 makes 42, right? So 2 and 3 and 7 are the prime factors of number 42. So this is called as prime factorization. For number 17, it is 1 and 17. There are only 2 factors and it is a prime number. Okay, then 102. So it can be broken out as 251 and 17 times 3, right? Yeah. So here 2, 3 and 17 are the prime factors for 102. Okay, now 3, 6, 8, 0. So this can be factored like 2. Okay, we'll start with the 4. So it is 920. This can be broken into 2, 2, and this again by 4, 2 times 3, 0, and this can be broken out into 5. So it is 46. This can be broken up as 2 times 23, and I think this cannot be further broken, but this can be 2 times 2, right? So how many 2's are there? 1, 2, 3, 4 and 5, right? Which can be represented as 2 power 5, and there's 1 5 factor, and there is 23 factor, right? So these are the prime factorization format of the number 3680. Okay, 3680. This is the way we can find the prime factors by building a tree. Okay, so having this knowledge of prime numbers and how to find the factors and what are the prime numbers available, okay, and a list of the prime numbers in a range, we are going to solve some problems, word problems. First is, what is my number? Clue number 1 is, my number is a multiple of 2 and 7. So it means 2, 4, 6, like that, right? It keep on going. And 7 is 7, 14, 21. These are the multiples, right? But it keeps on going. It's like, the clue is very, very broad. So we'll just take the second clue. My number is less than 100 but greater than 50. So we have to write multiples greater than 50 and less than 100. Let us start with the multiple of 7 because the number of multiples will be lesser in between this gap. So we'll start with that. Okay. So it is 56, 63, 70, 77, then 84, 91, 98, right? These are the multiples of 7, and that number has to be also a multiple of 2, right? So here we have cut down 63, 77 and 91 are not multiples of 2, so we eliminate those numbers. Okay, now we will see third clue. My number is the product of 3 different prime numbers. product of three different prime numbers. So this has to have three prime numbers as their factors. Okay, only that number is going to be selected. So 56, 28, right, 14, 7, right. So it is having 2, 2, 2 and 7, right. We want three different prime numbers as the factor. Okay, if anything is that, okay, so 56 also is eliminated. Okay, 70, now we'll see for 70. It is 2, 35, again we'll get 5 factorization, 7. So the factor is 2, 5 and 7. Okay, so three different prime numbers. So 70 is the three different prime number. So this is the number selected by the me. Okay, maybe just for us curiosity's sake, we will just find out what are the factors for 84 and 92. So it is 2, 42, 2, 21, 3, 7, right. So many factors, so this is also not eligible. 98, it is 2, 49, 7 and 7. So it is also having three factors only, but we want three different prime numbers, product of three different prime numbers. So this also loses the quality. So 70 is the correct answer. Okay, see how the knowledge of prime numbers helps us to solve the problem. So okay, now we'll see one more thing. Brenda is thinking of a prime number between 40 and 50. Between 40 and 50, what are the prime numbers? 40, 41, 43 and 47, right. And Josh is thinking of prime number between 10 and 20. So 10 and 20 is 11, 13, 17 and 19. Okay, the difference between the two numbers is 26. What are the two numbers? Okay, of the numbers there is a difference of 26. Okay, let's see. 47 minus 26 is 21. We don't have any 21 number. So 43 minus 26 is, okay, 17, right. So 43 and 17 are the two numbers which has a difference of 26, right. Okay, now we'll move on to the next problem. John is reading 435 page novel. If he reads the same number of pages per day and the number is a prime number greater than 10, how many pages per day will he read? So 435 can have factors of 5 and 87. Right, so this can be factorized further. Oh yeah, it can be factorized by 3. 8 plus 7 is 15, so 3 times, so it is 2 3s are 6 and 3s are 27, right. So it can be factored as 5, 3 and 29. So 3 factors are there. They want to find a prime number greater than 10, so 29. So it's the only factor that is greater than 10. So he is going to read 29 pages per day, right. So yeah, if he reads 29 pages for 15 days, then he can complete the